So in this presentation, at first I am discussing about the airplane's wing, the basic physics. The airplane's wing have many control systems, as like the thrust and you can say thrust, drag, lift. These are the basic physics principle. But in this slide, we will talk only about the surface control system presented on the main wing of airplane, that is elevator, rudder, aileron, and flaps. As I made the main wing of airplane, so there are only two functions, aileron and flaps. So here you can see the flaps in the between. I hope that's visible to all of you. The flaps are used for maintaining the ratio of drag and lift for the airplane, and the aileron are used to tilt the airplane on its horizontal axis. So the second point is, what's the airfoil? So airfoil is just a type of design through which we can maintain or control the ratio of drag and lift as per our needed. Here you can see the yellow part, the ribs 1, 2, 3, I think there are the 5 ribs, the yellow parts. They are called the airfoilic designs. So this is the basic physics behind the airfoil. You can see the relative wind. When the aircraft moves forward in the air comes perpendicular to the airplane. But the wings are not attached perpendicular to the wing. They are attached in a specific angle, that's called angle of attack. You can see there. After that, that's the airfoil. How is it work? We all are known about the Bernoulli's theorem, I think. So you can see there is a curvature of wing is higher at the upper surface and lower at the bottom surface. So the wind which are facing the plane have to cover less distance at the bottom surface and maximum distance at the top surface. That's why the speed of air increases at the top side of airfoil. And we know where the speed increases, the pressure decreases. Due to this pressure difference, the upper surface has lower pressure and the bottom surface has higher pressure. That gives a lift to the airplane upward in the air. After that, come to the stages of construction. What I made the airplane's wings model. The first stage was sketching and calculation. First, I made the foam sheet. I bring the foam sheet and I designed the airfoil according to my specification. As you can see, the angle at the top, that's 122.5. That's because I want the maximum wind span of length of wing. You can see the wing is leading from last edge to this edge. That's why I have to use the 122.5 angle. And in between you can see 3 servo motors that will control the flaps and aileron. After that, that's the same thing but in an advanced manner. You can see AF1, AF2, AF3. These are the airfoils. So I have placed the airfoils in the decreasing manner. There are total 12 airfoils. So this is the relation graph of between width and length of airfoil. You can see the bottom is 16 inches, the wind span is 16 inches. And the maximum, as you can see, the 0, it is maximum 1.5 inches. The 0 is at here. So at this point, the maximum width of airfoil is 1.5 inches. And the last one is 16 inch. There is the width is, you can see 0.5 inches. That's the relation graph. After that, first I make the skeleton body, make the base with a 3 mm foam sheet. After that, I stick the airfoils as per needed, as that in the sketch diagram. I added 12 airfoils. After that, it is strengthening the frame. After adding airfoil, you can see the ribs in between, the perpendicular ribs, that are for the strengthening the wing. Then there are some 3D printed parts. I just make parts with foam and take the measurements and give it to the Manjot, and he designed it on the FreeCAD. Then he gave me the 3D printed parts. I just give him measurement and he gave me the design. So all of the credit goes to Manjot. As you can see the part, 3D printing part, that's the hinge at the bottom. Now it's a servo motor and electrical. You can see the first 2 servos are controlling the flaps and the third one is controlling the aileron. you can see the servo outputs here, which I will connect to the Arduino and the servo tester. After it's my final model. Final model is here also, but I cannot operate it right now because of technical specification and shortage of time. As you can see the airfoil design here. I will show you that thing. Yeah, here it is. In this image you can clearly see the airfoil design of the wing. After that there's a testing of aileron of the wing. This leads to till the airplane on its horizontal axis. That's the aileron, and these are the flaps. You can see the flaps are used for the braking and for the lift also in the airplanes. Then there is the finishing part. After doing all the mechanism and the hardware, I go to the finishing part. That's the strobe light installation. You must have seen that in the airplane, the blinking LED. And that's the wing rack. This one is also used to reduce the drag. At last, that's my whole project, and at last my experience. That was totally very amazing. In this whole time period, I learned a lot of new things. First of all, the Bernoulli theorem. I get to know that the Bernoulli theorem is not limited till the book pages only. It have a very miraculous physical applications. And then I am very thankful to the Rajesh sir and the Irfan sir who gave me all the encouragement and the resources I need for this project. And I will be always thankful to Agastya Foundation and the Prabha Foundation who gave us that golden opportunity to be in this prestigious institute and be in the guidance of great personalities. And at the last, that's the end of slide. Do you have any questions?